Bismillah. Now, so the objective for this part is for you to be able to determine again the same thing, center of gravity or center of mass or centroid, but now using the method of composite bodies. What do you mean by composite? I will cover one in a bit. So now, in we have seen component in term of in the construction sites, for example, right? We can see a cross-sectional area like this, for example, right? I shape, T shape, etc. So it is basically combination of several shapes, like a rectangular and a rectangular there, right? So when we have combination of shape like this, we can actually have step-by-step calculation where we calculate for each shape and then we combine in the end, right? So that's where composite comes in, right? Another context is that, for example, if we have a big structure composed of several different elements and each different element has its own weight, so as a whole it is a composite combining all of those things, right? So this is another example. Okay, so in terms of the theory, in terms of the concept, I think we have this is similar to what we have learned before. Basically, each object have or can be considered as combination of atoms of small particles, and each particle will have its own weight. So as a result, the certain weight is the summation of all weight, and then we end up with this equation with the understanding which we have learned from before, right? The equivalent, and then the simplification, and where the location is for a single force, right? So basically, a moment divided by the summation of force or weight. Right? Now, this is basically a revision, but if you notice that the expression is different, if before we have something like this, if about an area, it will be something like this, right? This is what we have covered before. So the understanding is that integration is basically when you chop off the area into small elements and you add to get the total area or volume or mass, etc. So it is equivalent to this. This one is summation, right? Of course, if we have a curve that we have to integrate, then we will have to integrate. But if we do not have to integrate, then from here it's simply just like that. Oh, but we do not use CT then, right? Because we have because it's no longer differentiation. If you understand, this one comes from what we do when we chop off the element, then we have one small element with like dx or something, right? This is one element. In this case, if you have three different we can divide into 4 different segments. Each one will have its own weight, and each one will have its own, like this one, the x coordinate of the centroid, and each one will have its own area, for example, or weight. So summation of A is just summation of SA is basically this multiplied by this plus this multiplied by this, etc. It's similar to what we have done with summation of moment, right? Force times distance, force times distance, force times distance becomes the summation of moment, yeah, which is this one. So it will end up with something like this. This is if we are considering center of gravity, so it's with respect to W. So this one you can just change to volume, area, etc. as such. So far, is it? Can you follow? Even if you do not know what's going on, just memorize this equation, which you will have to apply later on, right? This A can be changed into W, M, etc. depending on what the question wants. Alright. So that's the theoretical part. And then, so when we have object like this, for example, you can divide into some basic shapes. So for example, you have triangle, square, semicircle, circle, etc. Right? So if we can divide, then we can use this equation to calculate. I think it should be more clear when we do some example. Yeah. Now, and this kind of, if you want to determine using what we have done before, using integration, we can still do this. But there's no point of doing so because it can easily be solved because the shape is known, right? Similar as we have, I think earlier we have done an example where we integrate like a square here, right? Have we done that? In the when we want to determine, I think we have done the example of this one to determine where is the location of which result in half and half and 1/3 and 2/3. If you look back in the previous chapter, right? We have done the integration to show that we get this one. So, but after that we never actually doing that integration back in because we just memorize. Okay, this is basic shape, we just memorize. So similarly can be happen here. If you want to do integration, you get the answer. But why do such a thing when we can just memorize the location of each and use it straight away? Okay, for step of analysis, so basically you divide into pieces of known shapes, and holes are considered as pieces with negative weight or size. Right? For example, you will have a simple like this. So it's just simply adding these two. Or if you have hole here, meaning the area, and this area is actually a minus area. Right? In the end, when you do summation, this plus this minus that one. Okay. So the same goes with mass, weight, etc. So that is what it means here. And then the second, market table with the first column segment number, the second column mass, weight, mass or size, the next column moment. Okay, can you follow this? This is teaching you how to make the column, but fix the coordinate and then apply. Now, to make things simpler, what does this mean? Okay, we go to the equation, right? Now, let's say we start with a very simple problem first. Let's say the thing that I've just drawn just now, right? Okay, this is the simplest one. Find the, if this is the axis, x, y, right? Find the, if the question says find the centroid of this, right? Centroid, meaning in this case, we want to find what is x, y. Right? It's a 2D, x coordinate, y coordinate. Now, so if you know from starting point, you know what equation you want to use. X equal to summation of x a, or summation of a, y equal to summation of y a, or summation of a. Again, this x and y is actually the wave, meaning this corresponds to the element, or in this case, the segment. Each segment area here is also corresponding to that corresponding area. This one is the full area, right? Now, based on this, what you need is you need x, you need y with x with y with, and you need a for each corresponding. So when you want to do the table, it's just simply, because first you will have the segment, let's say segment 1, 2. So we have segment where you have 1 and 2, for example. And then you want to have x and y, for example. Or maybe we'll to put a first. So area a, and then x coordinate, y coordinate. And then here we need xa and ya, so just xa, ya. Right? Basically, this multiplied by this one, you get this one, this multiplied by this one, you get this one, right? And then what you need is just xa divided by a. So summation of a is here, summation of x a is here, summation of y a is here. So when you want to calculate, you just plug in what is the value of summation of x a, divide by summation of a, you get the value here, right? So as long as you understand what equation that you need, if for example you need x, y, z, if it's 3D, then you have to have another z and then za. If the question say not centroid but center of gravity, then your equation becomes w, summation of w, so then you just change here to w, and the rest is just x, w, y, w, etc. Meaning it just tally with what you need in the end, right? So that's how you develop your table. Is that understood? Okay. So it makes the calculation very, very easy. Now, several remarks before we proceed with the example. These things, these two are coordinate. It's not a distance, etc. So if I draw like this, obviously this coordinate is positive. Okay, this one is here, right? Meaning x coordinate, y coordinate is positive. Here x coordinate, y coordinate. Now make sure when we say coordinate, it is from the axis. So for here, let's say this length is 3, you know this is 1, right? But the coordinate will be 1 plus whatever here, right? You know, understand this one, right? And if the axis is like this, for example, then this coordinate will be negative, etc. So normally if the question like in this chapter comes in the final exam, it should be very easy because you just make a table, plug in the value, use your calculator, and then you find the result. The only thing is that many students sometimes make a mistake in terms of the positive and negative, especially when you have something like this, or if you have hole like this, then the area must be negative here, negative whatever value, because it minus that area, right? So just take a look at those things. Otherwise, it should be a very straightforward calculation. So I think we'll take a look at an example. Okay, this is a 3D example. So we are doing with respect with volume. So we have this object here. 3 blocks are assembled as shown. Find the center of volume. So can you imagine what will be the equation? So center of volume x will be summation of x with v, right? And summation of v, y is summation of y with v, summation of v, z equal to summation of z with v, summation of v, right? So straight away we know what column we should have, right? So let's put it forward. So we have segment, and then we have the volume, and then x, y, z, x, v, y, v, z, v. Right? Now let's consider, let's say this is segment 1, 2, 3, right? The 3 blocks. It already basically separate that into 3 blocks there. So for segment 1, how do you calculate the volume? So the area of the triangle times the thickness, right?
Yes.
So half the height is
Height is 1.8.
1.8 and then 1.5.
1.5.
That's the area, right? What's the thickness?
0.5.
0.5. And then you get whatever value there. That will be the volume. What is the x? Okay, again, what is the x, y, z? Is this wave is coordinate of the centroid of that particular block or element, right? So what is the s coordinate of the centroid? 1, is it?
Yes.
Everyone get the same? Anyone not sure how to get 1?
2/3 to 1.5.
Any problem or no? Okay, just want to make sure. Okay, so x coordinate is, for this block, x coordinate is this axis, right? So if you look from this perspective, x coordinate is here, you have this block here, right? And actually this block is having some distance from the y-axis here, right? So this is 0.5 there, and this whole distance is 1.5. So do you know this distance?
4/3 times
So this is 1/3 of
1.5.
1.5, which is 0.5. So in total the coordinate is 1. And is it clear? By now you should already know this is the ratio is 1/3, 2/3 for triangle, and for rectangular is half at the middle. Right. So what about y coordinate?
Y coordinate is 0.6.
Of this block still.
Oh,
The center right. Huh? 0.25. How do you get this? It should be at the middle of the thickness, right? You understand the logic there? Yes. Okay. Z coordinate? 0 point? Huh? Is it? Is this one right? This is 1.8. Should be 1/3, right? Triangle, so 0.6. Okay, this thing should be very straightforward. It's just that if you have lack of exercise, you might make a mistake, and this is where your mark will be terribly, meaning you lose a lot of mark, because normally the way you answer here is just make a table and you put in the value, and then here is basically just this multiply by this one, multiply, right? And then in the end you have the summation. Now you will notice that any mistake anywhere will cause another mistake there and cause another mistake there, and you have the chain reaction like that, right? So that will be, if you make a mistake here, then obviously the whole thing will be wrong. So you can lose mark easily if you make mistake in this question, even though it's very straightforward and easy. So make sure, you do some practice to avoid mistake here. Okay, block 2. Volume is straightforward. Okay, let's see what you get. What multiply by what?
2 times.
Is it 2? Is it?
2.5.
Yeah, 2.5. So make sure you don't make this mistake.
1.8.
1.8.
0.5.
0.5. So this is where things like this is where if you straightly jump without checking, if you make mistake like that. So this, if you lose mark like this, it's I don't know what to say. Yeah, but it happened. It normally happen in the final exam if you are not careful. What about x coordinate? 0.25. All understand why? It's the thickness of that one in the middle, right? Y coordinate, y width?
1.25.
Huh? 1.25.
25.
In the middle between this 2.5 is that. Z is 0.9, and then this is calculation. Block 3. Area. Half. 1.5. 1.8. The thickness is 0.5. Okay. X.
X is 0.25.
Y.
Y is 0.5 plus 2
Huh?
is 0.3. 3.
This one is 0.5, right?
Yes.
The coordinate is
3.
3. Right? Make sure, remember this is the coordinate, not just this distance, right? You have 0.5 plus 2.5, that is z,
0.6.
0.6, 1/3 of the height. And then, so when you want to plug in this one, so you just, this is summation of volume, you get something here, summation of x v, summation of y v, summation of z v, oops. And then you plug in, you get the value straight away, the coordinate. So there's nothing difficult about this one in terms of the difficulty level. It's just that avoiding mistake is normally the thing, right? Any questions? Okay. So normally the thing about this kind of question is, I rarely see students that they cannot answer this one because they cannot answer. Normally the case is after they go out, alamak, I make a mistake. So that's normally the case, right? Because you will realize that you made a mistake of forgetting to add or minus or something. Alright, so yeah, it will end up in the table. And please break a table. Do not do it elsewhere, because normally the answer scheme is in the table format and we just check like that, right? So if you suddenly do not want to do a table, you can still calculate without making a table. You can calculate, but you are not helping yourself if you make the examiner angle, right? And then you get this answer there. So you can verify the answer, right? Any question? How to
calculate the
x? This one? Ini this one? Kau tak faham ini? Apa ni? Okay, meaning this one you understand? Oh, okay. Xv is because this is x, this is v. Okay, so xv is x times v. Yv is y times v. So this one is just calculation from what multiplied by what. This one is summation. That way. Any other question? Make sure you understand. Okay, because normally I would consider questioning. It will. Okay, I'm not sure whether it will come in the exam or not, because you will notice after this when we cover chapter 10. Chapter 10 also have two components. One is integration, one is summation like this. So normally if chapter 9 is integration, chapter 10 is something like this. If chapter 9 is something like this, chapter 10 is integration. So normally it's like that. Because normally the examiner will want to test both. Rarely that the examiner will test both integration. But if it comes, so it should be easy. Okay. Based on typical variable central information, what are the minimum number of bits? Okay, basically how do you divide this if you have to solve? How many segments do you have? Three, right? Basically we have a rectangular, triangle and triangle. Okay, I'm not sure why this question is here. Because it relates to, but okay, but because we also already have covered that chapter, right? Can you answer this? If you imagine this as a box with a handle like this, and you have a force pushing it that way, meaning it will lift it in this way, right? If you push it that way. So what will be the angle? Meaning when you have lifted it like this is the angle, right? What angle here will make this to tip over? Is it 30, 45, 60 or 90? Do you think?
60.
Based on the information given. 60, why?
2 times 3.
Oh, you multiply by 2. Salah. What's the concept here? When it's tip over?
Center of
Yeah, the idea is if the center of gravity is already on this side, the moment will be like this, right? If the center of gravity is still here, the moment will be that way. So it will only tip when the center of gravity is there. So when is the center of gravity exactly on top of this point?
36.
Because if this is 30, can you imagine? How to make it 90? So you have to have another 60 basically, right?
I think it's 45.
Okay, faham ke?
Oh,
Right. So when you leave 60 degrees, you have another 30 degrees, making that the center of gravity is already at the here. So any additional, it will go tipping over that side, right? So this is combining with what we have learned in the previous chapter. Okay. If you have area like this, how many segments will you divide? Do you think?
5, 3, 4.
5, 4.
4.
What do? You want to add or you will minus something? Add and minus.
Minus it, minus emission.
Of course, there are multiple ways that you can do, but I think the easiest is you have this one minus
Circle.
this one
Semi-circle.
minus this one. Now, when you have triangle like this, in the previous example, it is not the same. Meaning this one is easier to do it separately. But if you have like this, it's obviously what is it called?
Separate.
Okay. Symmetry, right? So it's already here, right? On this line, 1/3 the length side, right? Okay. Okay, just to check if you this is attention project. If you are paying attention, in this case, we will consider the big segment A, B, C, D minus this small segment D, E, F, G, right? So for the small segment, what is the coordinate x, y in the table? You will put. Because when you do the table, you will have x, y, right?
Yes.
For this small segment,
1.5,
what
1.5.
do you do? 1.5, right? Any different answer? Because sometimes if you forget to add, if you just this one is 0.5, so if you forget to add the coordinate, that's the issue here. That's just to check. Alright, so you understand this one. So the slide is only that short because the concept is actually very simple like that. It's just that whether you do exercise or not. Now, one thing that I have to mention though. So let me put this back. Now, in the exam, how to put this? Okay, I think there are some discussion among the lecturers, and many of the lecturers want to proceed with still open book in the final, like in the midterm, right? So it's up to you what you want to bring, but in your textbook, there's this table at the back, right? So if you need to deal with rectangular or triangle, basically you don't need to refer to this. You already memorize 1/3, 2/3, or half, right? But if you have circle, semicircle, etc., I think normally many of us do not remember, so you have to bring this one. So what I'm saying here is, if you do not have your textbook, or for whatever reason your textbook is missing this piece, it's up to you to bring the table on your own. Normally, the table will be given in the question paper, but because they say you are free to bring your own whatever book, etc., so we'll just expect you to. So I'm giving the information now. Now, so what we have in the table, for example, like this, right? Because I try to find, because I don't have the file, so this is from the internet. So this is an example. Obviously, this one, if you can understand this one, this height is 1/3 of this height, right? So that's how it is drawn, and this one is basically in the middle. But okay, for this part, ignore this one first because this one is what we will be learning in chapter 10 initial. So if you have, for example, okay, circle is simple, it's at the center. Semicircle, do you understand this? So this one will be 4r/3π. So let's say, just for an exercise, if you have this, because I don't. The slide is over, so I'll have to create a question. For example,
Pi R square per
let's say we have question like this, meaning this is whole. So let's say this is what? This is 3 meter, 4 meter. R is 1 here. This is logical. Just let's say R is 1 here. This is another 2 meter. And the height is 3 meter. Logic ke tak ni? Okay, to make the calculation simple, let's make it 3 also. Okay, let's say if you have this one, right? And you have to find the centroid. What will you do? Okay, just for, okay, we have X and Y, right? So your table will have something like, so your table, I'm not sure where I want to write. So if you have segment, and then you have X, Y, Z, and A, right? Okay, I'll just put this 4 because the rest you know what to calculate. You just multiply, right? So you just want to check the first step. So for example, let's say I say this is 1, 2, 3, 4, 5. Alright. So segment 1. What's X coordinate?
1.
If this is X axis, Y axis.
Or negative 1.
Negative 1. Correct?
Yes.
It's 1/3 here, but it's negative side, right? Y?
Negative 1 also.
Huh?
1.
Tak, you don't have set, right? This is 2D. Okay, Y? 1, right? Area is half 3, right? Okay, you know that one. Segment 2. The rectangle. What's X coordinate? 2, 1?
1.5.
1.5. Okay, the area. Okay, I assume the area is simple. 3. The triangle there. X coordinate?
3 is 5. 4 plus 1.
5. Meaning 1 plus 4, right? And Y coordinate? 1. Okay, what about 4? This one, the semicircle. X coordinate?
0.
0. Ada ke 0? It's symmetric. It should be there, right? Y coordinate? Which one? So 4/3. R of where? R is 1/5. We just plug in there. Yeah, 5 for this circle. X coordinate?
X coordinate 2.
Yeah.
4.
4. Y coordinate?
1.5.
Okay, because I'm not okay. It's assume it's in the middle, 1.5. Right. So I think this is an example of how you apply this thing. Okay, that thing, right? Because this one is straightforward. For area, okay. But for area here, I think the circle is straightforward. But for number 4 here, semicircle is
Segment 4, how do you get the one?
which one? This one. We apply. You apply this one. You have to refer to the table. And for semicircle, it says the coordinate here have this 4 r/3 pi. And in our case, r is 1. So 4 times 1, 3 pi.
Full circle you just go to the middle one.
Is it?
Full circle.
4?
Segment 5. Full circle.
This one? Okay, if the circle, obviously it's at the middle there, right? So just this coordinate and this coordinate there. Obviously I didn't specify clearly, but we assume this is the center there. If it specifies something, then it's effect this one, right? It should specify actually. You cannot just assume it's in the middle, but then because I created the question without that. Right. So this is just to show what you need to be able to do with respect to this table. Right. I think the area is simple. If you have quarter circle, for example, it becomes still I think 4r/3 pi also. This one. So just as long as you are able to refer to the table correctly, then it's okay. That's just my purpose of showing this one. And you have to have the table when you go to the exam, right? And make sure you are familiar with the table before you come to the exam. Meaning you have done some exercises so that you know. Because right now it's straightforward, but later on, when we cover chapter 10, we'll have this one also. So do not be confused of what is what and which is which. Alright, we have 3 minutes left. Everyone have signed your attendance. And I think some of you that was not here previously, you have your exam paper here. So after we, this is midterm, right? After we end the class, I'll just call your name and this one. For those who have collected already, you're free to leave. So with that, we end the session. Inshallah, subhanakallahumma bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.